questions from strength of materials for your AE TS GENCO and AMVI TS. The springs in brakes and clutches are used to apply the forces. They can as well be used for second one, third one, fourth one, but in other applications. In a tensile test on mild steel specimen, the braking stress as compared to ultimate tensile stress is less. It is less. Okay, friends, your curve is like this, strain curve. This is ultimate stress, this is braking stress. So this highest, this will be lesser. This is strain, this is stress. Stress strain curve for mild steel. The stress developed in a material at breaking point in extension is called, it's actually breaking stress. Some people call it as fracture stress, friend, but breaking stress is the nearest name. Yield point stress is the point at which the material goes into plastic state from the elastic state. Ultimate tensile stress is the stress at which the necking starts forming in the mild steel component or specimen, test specimen. For steel, the ultimate tensile strength, ultimate strength in shear is as compared to tension is nearly half. My friends, so this is normally in compared to tension, in shear the material components, especially ductile materials, fail at a stress which is almost half of the in normal loading or normal stress. A tensile stress is performed on a mild steel round bar. Its diameter after fracture will decrease. So this is how it is going to be after. So here it will get breaked, okay, get broken. So this is initial diameter, this is final diameter. Final diameter di, let us say this is do. Do is always less than di. Diameter at the fracture. The bucking load for a given material depends on what? It is going to depend upon slenderness ratio, area of cross section, modulus of elasticity. All these three, L by K ratio, okay friends? Length of column by radius of gyration ratio, slenderness ratio, area of cross section A, and also Young's modulus, that is modulus of elasticity. All these three things. So we can see that it is PB is equal to pi square EI L square. Okay friends. So I is equal to MK square. Okay. So L by K is equal to slenderness ratio. So everything E and everything. So it is going to depend upon L by K ratio, that's the slenderness ratio, and also modulus of velocity E, and also area of cross section. Right. So it is buckling load is given by buckling stress into area of cross section. Okay, friends. That's why everything it is going to depend upon. The Rankine's constant for mild steel column with both ends hinged is, it's a famous factor, friends. It is 1 by 7500. It is asked in many number of examinations. So this is your Rankine's constant. Right. So here are the Rankine constants for various materials: wrought iron, cast iron, mild steel, strong timber. Okay, it is almost 10 times. Timber it is 10 times than the mild steel. Okay, friends. So please observe the other values also. Rankine constant for wrought iron, cast iron, so mild steel and strong timber. During a tensile test on specimen of 1 centimeter cross section, maximum load observed was 8 tons and area of cross section at neck was 0.8 centimeter square. Ultimate tensile stress is equal to 8 by 0.5. Yes or no? Load by area. So that is nothing but 8 by 0.5. So it is going to be 16. So this is in ton, this is in centimeter square. So ton per centimeter square. The correct answer is 16 ton per centimeter square. A simply supported beam A of length L, breadth B and depth D carries a central load W. Another beam B of same dimensions carries a central load equal to 2W. The deflection of beam B will be as that of beam A. So definitely it is always deflection is proportional to the load. Okay, deflection is given by, friends, how much it is he is asking. He is saying the simply supported beam at the central, it is delta is equal to WLQ by 48 EI. Okay, So because all other dimensions are same, I is same, L is same, but it is proportional to W or the load. So because the load is doubled, so deflection is also doubled. Two shafts A and B are made of same material. The shaft A is of diameter D and shaft B is of diameter D by 2. The strength of shaft B as that of A is 1/8. It is proportional to D square because the D cube. Okay, friends. So because the diameter is made half, it is proportional to D by 2 whole cube. So that means 1/8. The strength. Actually, friends, this is this is T is equal to pi by 16 D cube into tau, right? So because tau is same, because for the same material, and the torque is also same, so it is proportional to D, right? This is called your this is ZP, polar modulus. So the strength is going to upon, in shear is going to depend upon the polar modulus, which is proportional to D cube. Because the diameter is made 1 by 2, it will be proportional to D cube, that means D by 2 whole cube, that is D by 8. Compared to initial one, it is 1/8. When a circular bar traveling uniformly from diameter D1 at one end to diameter D2, at the other end it is subject to an increase in temperature T, then the thermal stress induced alpha being the coefficient of linear expansion, E being the modulus of velocity for the material, we can see that he is asking the thermal stress, okay, alpha T D1 by D2. If D1 is equal to D2, it is alpha T. We know that, okay. But it is tapering, so it is going to depend on both the diameters. So alpha E D1 by D2. Alpha E D1 by D2. So you know that alpha per degree centigrade, right? Units are per degree centigrade. Temperature per degree centigrade. Into E, it is Newton per meter square. So this will get cancelled. So Newton per meter square. Okay, stress. These are the units of stress. You can easily check with the help of the dimensions also, units also, right, friends? So some formula you will be able to answer if you know the dimensions perfectly. D1 by D2 is going to give nothing. It has no dimensions because after it's a ratio of the same parameters. In a beam subjected to pure bending, the intensity of stress in any fiber is dash the distance of the fiber from the neutral axis is definitely directly proportional to. Okay, friends, this is directly proportional to, because you know that sigma b is equal to m by z, right? But z is equal to by I by y. Substituting that, sigma b is equal to, let us write that sigma b is equal to m by bending moment by I by y. So y will go up. So if m and I are constant, because I is it is going to depend upon the cross section, etc., moment of inertia, or the size of the your beam, okay, cross section dimensions, and it is proportional to the distance of the fiber from the neutral axis. Why is the distance of the fiber from the neutral axis? So it is like this, okay. So for example, your beam is like this, rectangular cross section beam. So it is proportional to the, this is your neutral axis, this is neutral axis. It is proportional to distance from the neutral axis. So at this fiber, which is maximum distance from the neutral axis, it will be maximum, bending stress will be maximum at the upper and bottom, top and bottom layers, it's maximum. But at the neutral axis, it is zero. There is no strain in the fibers at the neutral axis of a beam. That's why it is called neutral axis. When a beam is subject to a bending moment, the strain in layer dash is distance from. It is just now we have seen, friends. It is directly proportional. It is given in a different way. That's all. When a beam is subject to a bending moment, the stress at any point is directly the distance of the point from the neutral axis. Once again, it is given. So it is given number of times. He is asking the stress at any point is distance of the point from the neutral axis. It is actually, friends, it is wrong actually. So he is giving the answer, this is wrong, this is directly proportional. The strength of the shaft is judged by, what is this? This is going to be torque transmitted by the shaft. The strength of the shaft is judged by the torque transmitted by the shaft. So the more the torque transmitted by a particular shaft, the more is the strength of the that particular shaft. It is neither the length of the shaft, nor the diameter of the shaft, nor none of these. Okay, so this is a very important parameter for the shaft while judging the strength of the shaft. According to Euler's column theory, the crippling load of a column is given by pi square A by CL square. In the Euler formula, the value of C for a column with one end fixed and other end free is, so this is your D. This is your D. Pi square EI by 4L square. It is actually pi square B is equal to pi square EI by 4L square. So value of C comparing it is 4. One end fixed and the other end free. For both end fixed it is 4 pi square EI by L square. A pressure vessel is said to be a thick shell. So this is going to be depending upon the diameter and thickness ratio. The ratio of wall thickness of the vessel to its diameter is greater than 1 by 10.
The daredevils. Stunts
Okay, T by D is greater than 1 by 10. That means T is greater than D by 10. Then it is said to be thick pressure vessel or thick cylinder. The stress necessary to initiate yielding. So what is this? The stress necessary to initiate yielding is definitely, so it is going to be, let us see the answer. Okay, considerably greater than that necessary to continue it. Okay, so initially to yield we need more force and more stress than to continue that particular strain. So it is considerably greater. So once it comes into that yielding point, now it will take a sharp dip. We know this is the shear stress versus strain diagram. So here, so this is the yield point, right? So immediately after that, it is going to reduce, right? So it is going to reduce for some time. So once again, it will increase. So like that. So definitely, it is the stress necessary to initiate yielding is definitely considerably greater than the necessary to continue it. There is no question of stopping. Once it sets in. In the below figure, the plastic range occurs between C and A and D. Not D and E. D and E is the necking region, friends. This is your elastic region. So let us draw this elastic region. This is plastic region. This is necking region. Necking. This is plastic. This is elastic region. So from A to D, it is all plastic region. So between point A and D.
Big thank you for all the love.
A thin cylindrical shaft of diameter D, length L and thickness T subject to internal pressure P. The ratio of longitudinal strain to the hoop strain E. This is a good question, friends. So it is going to be M minus 2 by M minus 2 by 2M minus 1. M minus 2 by 2M minus 1. So it is a ratio of the longitudinal stress to longitudinal strain to hoop strain or radial strain, you can call it. Right. The object of caulking in a riveted joint is to make the joint. So this is once again a good question, friends. Leak proof caulking is done to prevent the leakage in the riveted joints. Neither free from corrosion nor stronger in tension, free from stresses. So it is basically to make the joint leak proof. Which one of the following is the correct torsion equation? So torsion equation T by J is equal to tau by R is equal to G theta by L. This is the correct equation, friends. So T is the torque, J is the polar moment of inertia, and tau is the shear stress, R is the radius, and G is the modulus of rigidity, and theta is the angular deformation. L is the length of the shaft in appropriate units. Every direction is always accompanied by a strain in its own direction and an opposite kind of strain in every direction at right angle shoots. Such a strain is known as lateral strain. This is known as lateral strain, and the ratio of the lateral strain E lateral by E longitudinal is called what is known as Poisson's ratio. It is equal to 1 by M. Okay, friends. where m is a integer. For example, your Poisson ratio is 0.33. Then your m is equal to 3. When a change in length takes place, the strain is known as, it is linear strain. Linear strain. Okay, shear strain will result in the change in the shape. Volumetric strain, it is going to be equal to the change in volume by the original volume. Lateral strain is the strain in the applied loads perpendicular direction. When a body is subjected to three mutually perpendicular stresses of equal intensity, the ratio of direct stress to the corresponding volumetric strain
Ido
is
ring
known
breaking
as
action.
bulk modulus. This is known as bulk modulus, or it is given by K. Bulk modulus. This is very important for liquids and especially gases. Gas and liquids, mainly liquids, friends. For the beam shown in below figure, the shear force diagram between
எவ்வளோ
A
டேஞ்சரஸான
and B.
மூவ்ஸ் ஆனாலும்
So,
அசால்ட்டாக
how
ரிங்குக்குள்ளே
the shear
லைவாக
force diagram?
பண்ணுறவங்க
It
தான்
should be
இந்த
parabolical, friends.
WWE
It should
சூப்பர்
be
ஸ்டார்ஸ்.
parabolical. It should be parabolical, right? Parabolical, right? And bending moment diagram will be cubic shape. Okay. So there is no question of inclined line, horizontal line, vertical line, inclined line. No, it is parabolical shape. Parabolical shape.
லேடரில் ஃபைட் பண்ணுறதா இருக்கட்டும், இந்த ஹெவி வெயிட் சூப்பர் ஸ்டார்ஸோட மின்னல் வேக மூவ்ஸாக இருக்கட்டும், இந்த சூப்பர் ஹியூமன்ஸ்க்கு எல்லாமே ஈஸி தான்.
Right. In a prismatic member made of two materials so joined that they deform equal and axial stress, the unit stresses in two materials are, what is this? Proportional to their respective modulus of elasticity.
Big thank you.
Proportional to two materials so joined. This is called Fletcher beam, friends. So this is called, the ratio is also known as modular ratio, and it is proportional to the unit stress in two materials are proportional to the modulus of
இதுதான்
elasticity.
எக்ஸ்ட்ராடனரி WWE சூப்பர் ஹீரோஸோட கதை.
Some would say
Unit stress, let us say sigma u is proportional to Young's modulus or modulus of velocity, and ratio of modulus of velocity E1 by E2 is known as modular ratio.
extraordinary things.
Such type of beams are also known as Fletcher beams. For a beam, as shown in the figure, below figure, when the load W applied in the center of the beam, the maximum deflection is, it is WL cube by 48 EI. WL cube by 48 EI. WL cube by 48 EI. Otherwise, it is WL square by some 16 AB, something like that, okay?
நமக்கு மறக்க முடியாத
So, if you
ஸ்டன்ஸ்.
substitute A, I, E is equal to B is equal to, let us just
உங்களோட அசாத்திய ஸ்ட்ரென்த்
remove
மூலமாக
that.
நம்மளை அண்ணாந்து பார்க்க
So,
வச்சிருக்காங்க.
if you substitute A and B is equal to L by 2 in the original equation for the deflection at the point C, we are going to get WL cube by 48 EI. Central deflection in the simplest order beam at the center with a concentrated load at C, that is the midpoint of the beam. When a body is subject to a direct tensile stress sigma in one plane, the maximum shear stress in the
The daredevils.
maximum stress is dash the maximum normal stress. It is B, maximum shear stress. Tau max is equal to sigma max by 2.
இதோ ரிங் பிரேக்கிங் ஆக்ஷன்.
Sigma max by 2.
Strike like thunder. Get out the way. Get out the way.
So we know that Pn is equal to P cos square theta.
For a brutal display of might.
Pt. T is the tangential. Let us say P is the stress. Okay, P by 2 sin 2
எவ்வளோ
theta.
டேஞ்சரஸான
Okay.
மூவ்ஸ் ஆனாலும்
So,
அசால்ட்டாக
put,
ரிங்குக்குள்ளே லைவாக பண்ணுறவங்க தான் இந்த WWE
45 degrees. Theta is equal to 45 degrees. Sin 90 is equal to 1. It is P by 2. And cos square 45. How much it is? Cos square 45. Cos 45 is equal to 1 by root 2. So 1 by 2. Okay. So you can get the from the original equations. Pn is equal to P P cos square theta, and PT is equal to P by 2 sin 2
பண்றதா
theta.
இருக்கட்டும், இந்த ஹெவி வெயிட் சூப்பர்
Right.
ஸ்டார்ஸோட மின்னல் வேக மூவ்ஸா இருக்கட்டும்,
The unit of strain, no unit. Strain has
இந்த
no unit
superhumans
because after all it is a change in the
எல்லாமே ஈஸி தான்.
ratio of the two quantities, similar quantities. E, change in length mm and length mm will get cancelled, and it has no units at all. Strain has no units. A beam supported on more than two supports is called overhanging beam. It is more than, it is, let us say, continuous beam. Yes, it is continuous beam. So your continuous beam will be something like this, friends. Right, so here some load will be there like this, right? More than one supports. This is your, and this type of beams are known as overhanging beams. So after the supports there is some length. These are called overhanging beams. Overhanging beams and continuous beams will have point of contraflexure where the bending moment is 0, right? But other beams like a cantilever beam, simply supported beam, they don't have any point of contraflexure. That is the point along the length of the beam where the bending moment is 0. Where the bending moment is 0, the shear force is maximum. Fixed beams will also have a point of contraflexure. A beam extending beyond the support is called, just now I was talking to you friends, overhanging beam. Neither simply supported nor fixed beam nor cantilever. This is your cantilever fixed at one end. This is your simply supported beam with supports at two ends, and I have shown you overhanging beam. So this is the overhang. Here I have a load, and this fixed beam is like this. Fixed beam is like this. This is the fixed beam. Both end fixed. It is also called encasted beam. So encasted beams are normally used to reduce the deflection and slopes at the fixed supports. A rectangular bar of length L, breadth B and thickness T is subjected to an axial pull P, then linear strain is given by, okay, so this is given by A, P by BTE, P by BTE, okay. So BT is the
WW
strain is
நமக்கு
equal
மறக்க
to
முடியாத ஸ்டன்ஸ் கொடுத்துருக்காங்க.
stress is load by area by Young's modulus, okay, but area is equal to BT, we know that.
அவங்களோட அசாத்திய
That's why
ஸ்ட்ரென்த் மூலமா
strain is equal to
பார்க்க வச்சிருக்காங்க.
load by BT is the area of cross section into E is the Young's modulus. P by BTE. P is the load. P by A, load per unit area is called the stress. Stress by Young's modulus is equal to strain, because stress by strain is equal to Young's modulus. The shape of cantilever for uniformly distributed load will be, it is, say he is asking friends, actually if there is a printing mistake, the shape of
ஸ்டன்ஸுக்கு பேர் போகும்.
uniformly distributed load, the shape of the bending moment diagram for the cantilever beam with a uniformly distributed load, this will be
இதோ ரிங் பிரேக்கிங் ஆக்ஷன்.
parabolic. For uniform varying load, it will be cubic. It should be shape of the bending moment diagram. It should be mentioned shape of the bending moment diagram. Bending moment diagram.
எவ்வளோ டேஞ்சரஸான மூவ்ஸ் ஆனாலும்
A column with maximum equivalent length has
இந்த WWE
one
சூப்பர்
end fixed and other end free. One end fixed and other end free. Okay friends, so this is actually, so you have to compare P buckling is equal to pi square EI by LE square, okay.
50
It should be
இருந்து ஜம்ப் பண்றதா இருக்கட்டும்.
LE will be equal to 2L. For one end fixed and other end free,
Lateral
it will be maximum.
இருக்கட்டும்.
So some for some
இந்த ஹெவி வெயிட் சூப்பர் ஸ்டார்ஸ்
configurations with both ends hinged, it will be L by 2,
இந்த சூப்பர் ஹியூமன்ஸ்க்கு
2L, L by
எல்லாமே
root
easy.
2, etc. Okay, friends? One end of pinned, that will be for L by root 2. In that case, L by root 2. In a stress state diagram, as shown bigger, bigger, the curve A represents what? This is for which material he is asking. So he has given the various stress state diagrams for various materials. This is for soft bronze. A is for the soft bronze.
Watching this show right now.
So E is for mild steel friends. So some of the materials are also given. Okay, low carbon steel, cold rolled steel, etc.
இதுதான்
But
எக்ஸ்ட்ராடனரி
that is for
WWE சூப்பர் ஹீரோஸோட கதை.
Some would say
You
there's
are
nothing more powerful than a
brass.
focused mind.
A cube subjected to three mutual perpendicular stress of equal intensity Px experiences a volumetric strain is equal to, it is given by the formula 3p by E
WWE-னாலே
into 1 minus 2 by m. So 1 by m, if you write mu, Poisson's ratio, it will be 3p by E, okay, 1 minus 2 mu. Let me write it once again. 3p by E into 1 minus 2 mu. This is the Poisson's ratio. Right. A beam of T section subject to a shear force of F. The maximum shear force will occur at which point? Neutral axis of the beam section. Neutral axis of the section. So shear force will be maximum at neutral axis, but bending stress will be 0 at the neutral axis. For example, if you take shaft also of uniform cross section, okay, so your shear stress will be maximum at the neutral axis. The distribution will be something like this. This will be maximum at the neutral axis, right? But outer and inner, outermost fiber and at the extreme points, top section above neutral axis and below section, bottom section below the neutral axis will be 0, right? But bending stress will be something like that. This will be, yes, this is compressive, this is tensile, and it is 0 at the neutral axis. So that's the difference between the behavior of shear and bending for a beam. Which of the following has no units? Strain has no units. Strain has no units. Strain has no units. Strain has no units. Kinematic viscosity meter square per second.
WWE
Surface tension
மறக்க முடியாத
Newton per meter. Force per unit length. And bulk modulus is Newton per meter square or Pascals. I have given simple units, friends.
நம்மள அண்ணாந்து பார்க்க வச்சிருக்காங்க.
The length of a conical bar is L, diameter of base is D, and weight per unit volume is W. It is fixed at its upper end and hanging free. The elongation of the bar under the action of its own weight. Such type of questions are also asked, friends. So the material, if the material a weight is more, then definitely it will be elongating under its own weight. So in this case, what is the correct answer? It is actually
இந்த டேர் டெவில்ஸ் ஸ்டன்ட்ஸ்க்கு பேர் போகும்.
it should be like this ones. Let us see this actually. So for this particular case, it is C. WL square was 6E. 6. So you can easily remember because this said volume means it is a 3-dimensional figure, right, friends? So 6 is having something like it is a multiple of 3, right? So this is wrong, this is wrong, this is wrong. Okay. So for cubic dimensions, you have got 3 dimensions. Okay, friends? Like LBH3. So 3 is involving here. WL square by 6E.
எவ்வளோ டேஞ்சரஸான
For no other thing, it will be having a
அசால்ட்டா
factor of
உள்ளுக்குள்ள
3.
லைவா
So that is the correct answer.
இந்த
So you can
WWE
easily remember this particular bit like this. Next, in a compression test, the fracture in cast iron specimen would occur along where, so it is going to occur on an oblique plane, neither the axis of the load nor at right angles to the axis of the specimen would not occur. It definitely it will occur. The fracture will occur. It's a cast iron is a brittle material, and it is not going to suffer any deformation before actually fracture, unlike your ductile materials which undergo lot of deformation before the failure or fracture. Okay, so here it is going to occur along the oblique plane. So in the beadings also, friends, you see that the concrete beadings also, you see on the walls some cracks will be coming, right? So you see, if you see them, they will be along the 45 degrees direction, right? So why? This is the reason. So the failure will occur, fracture, so will occur along the oblique plane. A closely coiled helical spring is of mean diameter d and spring wide diameter d, small d. The spring index is the ratio of d by d ratio is called spring index. Okay, this is called spring index. D by d ratio is called the spring index, coil diameter by wire diameter. Okay, d by d is called spring index. D by d ratio is called spring index. And the load per deflection, W by deflection, this has got another name, friends. Spring rate, you can say that spring rate, that is load per unit deflection. Load per unit deflection, it is given by K. Newton, load will be newtons and deflection will be mm. Normally, very small deflection you can take for the springs, it will be Newton per mm. A fixed beam is one which is fixed at both ends, both of its ends. One end fixed, it is called cantilever. It cannot be fixed in the middle. None of this cannot be answered. For a shaft, the shear stress at a point is dash, the distance from the axis of the shaft. It is directly proportional. It is inversely proportional, actually. So it is inversely proportional to. It is inversely proportional to. So if you see the what you call this circular section also, you see, right, this circular section, for example, I've got circular section, the shear stress will be something like this, right? This will be maximum. So this is, let us say, neutral axis, right? So it is gradually decreasing towards the outermost fiber, right? So it is inverse proportional. It is wrong, actually. Directly proportional is the wrong one. But that is, in case of bending, it is directly proportional to the distance from the neutral axis. Outermost fibers will be at the longest distance, so that they will have highest stress at the top fiber and bottom most fiber. But their nature is different. Compressive on one side and tensor on one side. It will depending upon the action of the or the direction of the load applied. The relationship between modulus of velocity and modulus of rigidity is given by A.
In the Daredevils.
He is asking, so modulus of velocity and modulus of rigidity is equal to, you know that, 2g into 1 plus mu. 2g into 1 plus mu. Mu, if I write 1 by m, Poisson's ratio in terms of some integer m. So if you substitute and get g or c, he is calling it as c here. So I have taken it as g. So if you substitute that, simplify that, you are going to get me by 2 into m plus 1. Friends, in this video we have seen some basic and good questions, conceptual questions from your strength and materials for your either AMVI, TS or TS GENCO AE to be conducted probably in 1 month or so. And you are having assistant model inspector also examinations. In the recent press conference also, press meet also, our CM has told that 2 lakhs vacancies are going to be filled during this year 2024. So definitely we can expect notifications from different examination, engineering, AE, AEE and assistant motor vehicle inspector. Assistant motor vehicle inspector notification is going to be given in June in the first sense, in the first phase, and then December in the second phase. So I am offering online batches for these examinations: AE, AEE, assistant motor vehicle inspector for mechanical engineering branch, including your AE GENCO or your transfer, whatever it is. Okay, friends. So if you are interested for any SSC exam, staff selection commission examinations, or any other competitive examination involving the mechanical engineering, you can call me or mail me on the mail ID and mobile number which I am going to provide in the description box. In the next video, we are going to come up with yet another important topic for your examination point of view. See you all. If you like my channel, subscribe and share among your groups of friends. See you all.